he is on the website. But unfortunately, I also forgot to brief on what you're going to talk about. So it had something to do with traffic management using Excel spreadsheets and saving money, I guess. That's the important bit, right? Your slides should be on this machine, I hope. I don't know. Well, I also don't know. That's the... Let me check. You've got them on a stick, or? Ah, Savior. Then I would just plug it in. No? There we go. Hello, yes. Oh, that's not the one. Okay, so this one, and I'll let you pick which version it is, because obviously I don't know. Okay, I'll double click and open, or drag it to the desktop and. How to make it big? Oh wait, this is a. Is this PDF or what's the format? Okay, then would you just if you use this one, file open. There we go. It's this one. Let's open and view. Where is it? Full screen mode. Well, in the meantime, let me hit this button then. Oh, that didn't work. View. Oh, view full screen. No. View full screen mode. There we go. This looks a lot better. Okay. Sorry for the interruption. I normally never use computers.
So, okay. I'm Fredy Künzler from INIT7. I've been around a couple of MENOGs now, and I hope that this topic, which actually came up during FPIF in Casablanca about 3 weeks ago, that was a late addition to the agenda, traffic engineering with Excel. So we've heard presentations about BGP engineering, what you can do with communities, what you can do with more specifics and all that. And what I figured that is often in this community, the people attending, they are not really technicians. They probably know what an ASN is. This is what you require to understand this presentation. But I'm not going to talk about more specifics and BGP communities and prepending and all that. So it's a pure Excel sheet we're going to present here in this presentation. And I hope this attracts your interest. Disclaimer, that's me, contact information, and a few words about INIT7. We operate the backbone, AS13030. I'm going to skip that because I was told to be quick. So you have an idea where we're operating. We have a number of pubs across Europe. The latest edition is Marseille because submarine cables are landing there. But this is also no news. I'm going to talk mainly about money today. So when you buy IP capacity, and some of you do, how do you choose? You choose by price. So vendor one says, oh, you get 3 megabits for the price of 2. The other says, you can get 1 megabit for only 4,000 Italian lira. But this is silly. This can't be a decision from whom to buy. There are a number of myths around in this field, in this industry. There's nothing but transit and public peering. This is not true. There are paid peering, there are content connects, there are partial transit, there are European transits. All kinds of options of IP capacity. I'm coming to that later. There's another myth. A tier 1 is the preferred supplier. Tier 2 is second class. This is also not true. It depends what you want to achieve. Usually, and I see this from the experience we have in the last years, I'm operating networks, usually a combination of tier 1 and tier 2 shows the best result. Because a tier 2 has a strategic advantage over a tier 1 and can produce IP capacity more efficiently, which usually results in better pricing. A tier 2 doesn't have to cover the whole internet. He still can rely for a little subset on a tier 1 and he's cool. While a tier 1 must do a much bigger effort to reach everybody on the world. Myth 3, public peering reduces transit costs. We've heard that a minute ago from Marco. And if you believe all the marketing blah blah of the big exchanges, I mean, they want to sell ports, which is fair. They usually say public peering reduces your transit costs, but it depends. Yes, but it depends. It depends on the amount of traffic. It usually scales only from about 10 gigabit upwards. Otherwise, you're not cheaper. And it also depends on skills of your network engineering crew, because to maintain hundreds of peers is quite a bit of work. And last but not least, what we all see, transit is meanwhile so cheap, at least in Europe, then peering often doesn't pay off anymore. So what is our goal from a commercial perspective? We are supposed to deliver sufficient IP capacity for end users, because congestion sucks, and if we do the public transit analogy, the travel in the bus on the right is probably more comfortable than the journey on the bus on the left, because packets may fall off the bus. That is not what we want. But on the other hand, since we're commercial people and we have to go with the budget, we have to maintain it. I mean, everybody could build the best network in the world if with the best user experience, with no congested links at all, but it would cost a fortune. And since capacity is constantly growing, so the end user wants more for the same, more bandwidth for the same amount, the CFO of your company probably gives you a hard time. What we observe in the past years, and I think this is valid for almost every network, the end user the usage per end user is rising, but ARPU remains the same. Last year they used on average 200 kilobits, this year 400 kilobits, and in 2-3 years, as soon as Netflix shows up in your country, in your network, they want 1 megabit per second on average, or even more. So I thought about setting up an example challenge. I assumed any Middle East ISP in any Middle East country, an eyeball provider, they have this year 100,000 broadband customers. The average bandwidth per user is 400 kilobits. That results in total traffic of 40 gigabit. And they purchase from 4 different tier 1 carriers. Each carrier supplies with 10 gigabit capacity in Europe. So they go and buy STM64's 10 gigabit links to Europe on various submarine cables for redundancy, and they just plug it into networks of tier ones in Europe. That's my assumption of today's example Middle East ISP. The traffic ratio they see is about 8:1 in terms of in favor of inbound. So if we do the Excel calculation, what their cost have as of today, they buy 4 10 gig links, each for $100,000 a month. They buy some IP capacity from vendor C, G, L, T with different costs. Sums up in total of $450,000 per month. The letters I've chosen are not just A, B, C, D. There you can guess what I thought. Well, okay. As of today, they have 100,000 subscribers, and the average cost per user would then be $4.50 per month, which they can subsidize in the revenue they have with the DSL or whatever connectivity or technology they use to connect their broadband subscribers. Now we're going to year 2014. The Middle East ISP, our example ISP, still is an eyeball provider. The traffic ratio changes a bit, it's 7:1. So people are starting to use more outbound traffic. It's a change. It goes into more balanced traffic ratio, but it's still insignificantly. Their marketing department does a lot of effort to connect new customers. They grow by 50% to 150,000 users, but at the same time, the users eat more bandwidth. They also go up by 50% in this example, total traffic, 150,000 users, 600 kilobits, total traffic, 90 gigabits. So if we continue to purchase just the same way as we've done that in 2013, the capacity would grow by 220 to 225% of today's cost, while the revenue remains at 150% because the assumed ARPU, average revenue per user, just remains the same. So even though we have 50% more customers, our cost will grow more than 50%. That would be the calculation. Excel sheet again. I assume that we can talk to our vendors and get some rebate. If we buy for the 90 gigabits, we need 9 STM64s on submarine cables. We can talk them down a bit, so we get a discount of 20%. Same with all the IP capacity vendors. So we go to them, say, okay, I'm going to buy more from you, but I want a better price. So this is usually how the industry works. Summing up, total cost $810,000 per month, divided by the broadband subscriber of 150,000, and this will end up with $5.40 per user. That's more than we had last year. So you go with that calculation to your CFO and he says, go home, do your work, do your homework, this is not going to be approved. So what now? We have to become a bit creative. Face the facts, ARPU remains stable, but the bandwidth per user is rising. So it's $90 more per user. What can we do? Buy cheaper? Yes, of course, but we already talked down the vendors. So we get approximately 20% rebate on renewals and upgrades. STM64 submarine capacity gets cheaper because there are more cables, more market in this space. But unfortunately, sometimes we face long year IRUs, and as we know, IRU doesn't really scale. Well, sometimes it does, but sometimes not. We can also consider local peering. Absolutely, we should do that, but it would only substitute about 5 or maybe 10% of the transit. And last but not least, as the ideas, as we run out of ideas, we certainly can do content cache servers with our friends of Google and Akamai. We probably should start rethinking our buying strategy. So far, we just went to the market and said, okay, I'm going to buy IP transit. I need 20 gigabits. Who gives me the best offer? And you get quotes. The same, of course, for submarine transport. But the question is, do you really need IP transit? If you look at the airlines, and I often do analogies with the airline industry, because I used to be in my youth working for a travel agent, so I have some ideas about airlines. If you want to fly to London, you're not going and buy a ticket to New York, and then halfway you jump off the plane by parachuting, or you just walk out of the plane which stops in London. You buy a ticket to London if you want to go to London. And if you know what you want, where to go, you buy the right ticket because you would save money. This doesn't happen often with IP. If you know your backbone traffic before purchasing IP transit and submarine transport, then you probably would buy different. This is in fact much more important than just shopping around for the best price. So we already said, you've seen that picture before, it's silly, just buy capacity by price. This might not end in a good result. And now I come to Paolo's presentation a minute ago. You need telemetry data. You have to know the top 20 traffic sources of your backbone by percentage, because it could make a huge difference in your capacity purchasing bill. And as Paolo already explained, every router of every major gear vendor supports NetFlow or SFlow, and this easily produces raw data traffic statistics. So you can use PM, ACCW, or you can NFSen or whatever. So you get flow stats. And these flow stats can be aggregated, and they can produce nice and easy readable traffic graphs by source ASNs. So this is how it would look like. We, at INIT7, we use AStats. This is also a free open source tool to aggregate and display traffic flows. And in this example, we see that Google produces some traffic and some other IP operator has traffic, etc. So this is what we want to see. We need easy readable statistics, because even though if you're not technical at all, you probably know that what a megabit and the gigabit is and how much it costs. Let's assume this example ISP we were talking a minute ago has finally the analysis of their traffic. And, surprise, surprise, the top 5 traffic sources, or ASN, are probably responsible for about 40% of the traffic. And if you look further, top 20, another 40%, and the top 100, another 10%. And then all the other thousands of ASNs around the globe, they are just irrelevant. They just make the basic noise, and that's it. So we don't need to think about those. So some of the top 10 sources are likely Google, YouTube, Akamai. They told me recently they have a build capacity of about 15 terabit. Then probably Microsoft. LeaseWeb, a large server operator in the Netherlands. I have recent information, they have about 2 terabits of built IP capacity. Limelight and a number of other names. What we also see is the geographic scope of the origin, traffic origin. So maybe 5% are from Middle East, 65% from Europe, United States 20%, and the rest of the world 10%. These are just raw assumptions. This is not based on any real data. This is just raw assumptions from the experience I had in the last years. But on the other hand, it's obviously, it showed up recently on Telegeography. On September 18th, they did a press release. Europe emerges as a global internet hub. And I quote here from the link you can see on the bottom. Why Europe, the continent, benefits from IP transit prices that are among the lowest in the world, geographic proximity, and is home to many large carriers and major internet exchange that provide rich peering opportunities. Europe also benefits from a multitude of submarine cable landings, new cable builds in Africa and the Middle East, etc., etc. So that's why Europe becomes a global internet hub. And a lot of traffic is sourcing from Europe to your country. So we come to the conclusion. We need to focus on the fat boys. How can we handle their traffic more efficient? So 2 of the top 5 are rather easy. If we talk to Google and Akamai, we can deploy their cache servers within our own example ISP network in our own data center, and these local caches will substitute a big chunk of the IP transit traffic. On the other hand, buying full IP transit from 4 vendors is probably a waste of money. Less than 30% really require full transit because we only see about 20% US origin and 10% rest of the world. And as I said before, no one is going to buy an airline ticket for New York and jumps off the plane halfway in London. So you may want to consider to ask your vendors for partial transit or European transit because this is cheaper. And don't mix that with paid peering. It's a partial transit. And the conclusion number 3, peering locally certainly helps because it could also probably offload 5% of your total transit traffic. Hopefully, one day it will be much more. For the continent of Africa, they said the goal is to have 80% local traffic in Africa and 20% global by the year 2020. This is a goal from ISOC, from the Internet Society. Then there is also the option of peering in Europe. That could be very effective, but it has to be planned well. Don't underestimate the required long-haul capacity. If you have currently 100 gigabit of traffic and you go to DKIX or M6 with a 10 gig pipe, that won't be sufficient. So buying European transit or partial transit from a well-peered network could be hassle-free. You don't have to have the engineering skills, and it just could have the same effect as remote peering in Europe, just for a little more. So we go with our Excel calculation to the CFO again. We assume that we just need 7 submarine cables, 7 10 gig pipes or STM64 submarine, we need 20 gig of IP transit vendor C and 20 gig of vendor G. And then we buy 30 gig of partial European transit, plus 40 gigs of Akamai and Google caches, and plus 10 gigabit of Middle East peering. That sums up on a total of 120 gigabit of capacity instead of 90 we had before. It sums up of $618,000 dollars per month. Again, divided by the broadband subscribers of 150,000. Cost per average user is $4.12, which is lower than we had last year in 2013. It was $4.50. And despite that, the average usage per user went up 50%. From 400 kilobit to 600 kilobit, the average cost is down, and your CFO loves you for this. And on the other hand, capacity is over-provisioned. The actual demand is 90 gigabit, but the build capacity is 120 gigabit, which results in happier end user. This is probably also an advantage for your marketing department, because you're competing with your with other networks in your local market. What I didn't consider here is capex and labor costs, but I mean this would be probably beyond the scope of this presentation, and I hope that my calculations make somewhat sense. And I come to questions now. Thank you.
Ready?
No nasty questions, please.
And Jan has a question, I see.
Yeah, Jan-George. It is not a nasty question, it's a sustainability question. So I like the idea, but okay, if I do this year, I cut down the cost. For how many years I can keep going with this and reducing the cost so the CTO would be happy?
That's a good question. The sustainability of this model. Assuming that next year they will eat up 800 kilobit per user and the ARPU still remains the same. I believe, I mean, if we go back to the calculation here, the majority of cost is the wet capacity, submarine transport. And the demand of this submarine transport will still rise, but I trust it will come one day on a level like transatlantic or wherever. So transatlantic submarine STM64s you can buy for much less than $10,000 a month. The same is actually valid now, obviously also between Marseille and Egypt. So you can buy wet capacity for less than $10,000 a month. So we're already halfway to the Middle East. Submarine capacity is expensive in the Middle East because of other issues such as regulatory or monopoly on half circuits or whatever. And I think that has to be fixed someday in the area by the community itself if it should be sustainable.
Yeah, but well, so with this you can probably maintain the costs throughout the years, but then the CTO would come and say, oh, but last year you reduced by €1 or $1. Can you reduce it for another $1?
I think so, yes. Maybe.
Okay.
If you can cut down the STM64 capacity to $50,000 or $30,000 or $20,000, because there is no reason, there is no actual cost justifying that high amounts.
So probably the best strategy for being a technical person, not the CTO, is to cut down the cost every year just a little. Not to cut it all the way down.
The job of the technical stuff is to provide good quality to the end user. That is what counts. And the business people will care about the calculation. And of course they have to fight and they have to deal something together to come to an appropriate solution which helps the company and also the stakeholders, the end users.
Okay, thanks.
I've got Marco in the back.
Yeah, you know, I want to say something about this. I think this calculation and especially your future outlook of, oh, you have to reduce your STM64 costs, your wet capacity costs, this assumes that Europe is the center of the world when it comes to internet, which we Europeans, of course, love to hear, and we would like that this will stay forever. But honestly, I think maybe I'm too peering enthusiastic and I'm too enthusiastic about what is happening now in the region. But I think at the end of the day, the only solution for that is that you don't need so much wet capacity to Europe to get the traffic from there. And if you think about, if you make it possible for Google, and it's already possible and it's already done, Google and Akamai to come here, which are the top players on your list. For LeaseWeb it might be a bit different because of the certain traffic they have. But for other players it will be the same, then you will reduce your STM64. And the second thing is that why we have so much traffic in Europe, because Arabic content is hosted there because of cost. It's not affordable, so for, let's say there, I don't know if you know that there is an Arabic version of Hulu. So it's, I always forget the name, it's from NBC. From
ICFlix.
Yeah, no, Shahed, yeah. It's Shahed. And then there's Arabic Netflix coming up. I also, sorry, what's the name? Okay, Shahed and the other platform. And it's hosted in Milano at the moment. So all the traffic is coming from Milano, and if I know from these guys that they only have to STC during the year 3 gigabit of traffic, and in Ramadan 5 gigabit of traffic. So STC is paying money to us to get it, which we love, of course. And if you see the whole GCC region, yeah, it's a lot of money and a lot of traffic. But what is happening with an internet exchange, they're coming back and the traffic is local. So I think you will see much, much more Arabic traffic coming back to the region in future. And then you can reduce this on the long term.
I 100% agree to that. It's obviously, as of today, more attractive for these content owners to host in Europe. But why? Probably they just have to face too high bandwidth costs in the Middle East. I mean, we assume that a colocation space has the same price in the Middle East as in Europe, because power has a price, etc. But the transit cost in the Middle East is 10 times or 50 times higher than in Europe, and that's the problem. So I have another presentation I gave recently why web hosting in this area could become more attractive if the capacity owner would sell their excess bandwidth for really cheap, their excess outbound bandwidth for really cheap. So if I would show up having much content to addressing to this population here in the Middle East, I would talk to them and say, look, I'm just paying my inbound capacity, but the outbound capacity should be free, because you have it anyway unused, and it would help you to reduce transport costs to Europe. Otherwise, I set up my servers in Europe because there it's much cheaper. And I think that's the problem, that content is not coming to the area here.
I think it's not. Yeah, this can be solved also by engineering, because you can get rid of the traffic, you can get over peering here, and the rest you serve out of Europe still. This is done by many content providers, and it's possible. This is just an engineering thing. I think I see the main reason why, or yes, as you said, it's the pricing is the reason why people host their content in Europe at the moment. But when they have the possibility to get rid of this content on a cheap way, like peering here, they can do it. And the main reason why it didn't happen till now was that till now, whenever you went to one country, to one data center, you could peer exactly with this one company, maybe in Bahrain with the Bahrain companies. But you were still locked down to this one data center, one region, one country, maybe a couple of ISPs. And when you think about the technical issue and about the financial issue and also regulation, bringing server to a country sometimes was difficult. And especially for media companies, it's not their business. They want to have an easy way going. So that's why I say we're just on the start, that you will see that coming back, and I think the whole region will benefit from it at the end of the day. Because I don't think this will be only happening in Dubai, this will happen everywhere at the end of the day. Or I hope it will happen everywhere.
Yeah, Bashar Abdelhadi from Kuwait.net. Being a hosting company, maybe I could add some information about hosting locally. We used to host our servers in the US back then. Then we moved to Netherlands at Amsterdam. Basically, the idea was not saving money, it's less latency, because for us, reaching anywhere, it's beyond 100 ms around the world. So when we asked back then to move to the region, for example, in Dubai or in Doha, the prices was very expensive to bring the content inside. And the users, anyway, they're exiting the region for reaching other sites. So it doesn't make sense to bring and pay double or triple or maybe more just to serve, you know, few milliseconds less. So with internet exchange coming to the region, I believe this will help a lot of us, you know, companies like us hosting outside to bring the content inside. We had some talks with ISPs to use their outbound bandwidth, which is unused actually, and they were very interested to partner in a way or another, but it didn't yet click. So it is happening. I believe, you know, having internet exchanges would help to, you know, slash these prices and making a lot of CFOs, you know, happy and smiling.
Okay, I think I've got another question in the background or comment.
All right. Thanks. Philip again from Datamina. I have to say I very much agree with the approach here, but one type of traffic that I see notoriously missing is Asian traffic. And as an ex-operator, we've seen in the region predominantly European traffic, but the growth in Asian traffic, specifically Chinese, is staggering compared to the growth in European traffic. So if I were to plan a couple of years ahead, I would make sure that I have a good way of procuring Asian traffic or reaching Asian sites at a cost-effective way. This said, I have a couple of questions about the very first slides that you presented, if you don't mind.
Sure.
I wanted to ask, you said that Tier 2s can offer cheaper transit than Tier 1s. I wasn't quite sure what you meant by that. Could you tell me how it works? There you go, that's the one.
The strategic advantage of a Tier 2 is that if we again look at the model where the traffic actually originates, the percentage of the rest of the world they have to reach somewhere is relatively small. So we have the long tail. So the top 10 source ASNs, a Tier 2 picks up the top 10 or top 20 or top 100 locally. And only a few networks are far away. So INIT7 is a Tier 2 operator. We don't build to, let's say, New Zealand, because that's beyond scope of cost. I just buy from someone, from some Tier 1, a little chunk of IP transit, of full transit to fill my routing table with exotic destinations I cannot reach. That's the point, what I meant here. So the big chunk of traffic I pick up with peering for free or for low money, and I don't carry that far. I just carry it, let's say, from London to Frankfurt or wherever, small distances for cheap. Just the few percent of traffic I cannot reach myself with peering, I buy from some vendor which has decent connectivity, and that is, from a cost perspective, much more efficient than building a network all over the globe.
Understood, thanks. I had another question. You said that transit could be cheaper than peering at sub 10 gig levels.
Yes.
Was that calculated on European transit prices or
European
yeah. Plus backhaul to the Middle East?
Absolutely. It's calculated on, where was it? Here. No. No.
But
anyway.
Fredy, I can sign this. I sell D-Kicks, but I can sign this. It's true. It's one of the things I mentioned in my presentation, that this main argument is not valid anymore in all circumstances. When it comes to below 10 gig, yeah, it's cheaper to buy just transit. Yeah. So you need other arguments to justify the peering. That's the point. That's our issue as well.
Absolutely. And the question is, what do you want to achieve with peering in Europe? At D-Kicks you pay 1,500 euro for a 10 gig port. You have to have a router, you have to have collocation and all. If you sum up all these costs, plus transport and plus engineering, etc., then it just scales up from 10 or 12 or 15 gigabits. And over the last years, we observed that the level where it really pays off, only from a commercial perspective, the peering, went up and up and up.
Yeah,
that's the thing. Yeah. So if you just want decent connectivity to D-Kicks, M6, etc., and have probably 2, 3, 4 gigabits of traffic, you'd rather sign up with a network which already has all this peering, they give you a good rate.
Okay. Anything else from you? Or okay. Yeah. Well, yeah. We can continue. We can continue over a cup of coffee. I think it's getting really late now. Thank you, Fredy. And
thank you. Thanks for the
thanks
attention.
for your time. I really love it. This is as somebody said to me, Philip, write a book. Write a book. Do it. Well, that's it for today. Thank you. Yes. Not for MENOG. Of course, there's also tomorrow, and tomorrow is another day of presentations. Starting off with a panel discussion with. Bashar is going to lead about IDNs and international domain names and internationalization. So please be back here tomorrow. We've got another half day of exciting content for you and a lunch afterwards. So we'll be waiting for you here with coffee at around 8:30, and conference will start at 9. So please be careful when you go home. And please be back tomorrow. Thank you for today. As we mentioned, all the presentations are online, and as soon as we get back to Amsterdam, we will also publish the videos that we've captured during the webcast, so you can look back to the things that were said today, and you can send the link to your colleagues who unfortunately couldn't make it here. So thank you all. There's still a few T-shirts in the back, and if you're with the car and you parked it, Sandra has some parking tickets available. So unless somebody really wants to say something right now, I'm gonna thank you all for being here and close this session. Thank you, and see you back tomorrow.